Hi everybody! So today's video is going to be about Module 2 Task 6, which is Task 2.6. Our learning target today is I can write a linear equation. So we're going to be writing equations today given multiple contexts. So we might give you a point and a slope. We might give you 2 points, or we might give you a graph, and we're going to ask you to write equations. Now, what I'd like to do is start by reviewing how we can write linear equations. Now, you're going to notice this is very similar to what we did in Module 1 with a little bit of a twist. So in Module 1, we learned that we can write equations by just looking at the pattern in the table. In this module, however, we're going to be looking at tables where the x values do not always go up by 1. For example, it goes 0, 2, 4, 6. Those are going up by 2. Or 4, 7, 10, 13. Those are going up by 3. So in this case, instead of just looking at the pattern in the table, we're going to be starting by looking at the slope, which takes into account that the x's and the y's are both changing. So the first thing you're going to do whenever you want to write this type of equation is you're going to find the slope, and you're going to do that by finding the change in y divided by the change in x. So in this table, the change in y would be going from 6 to 4 is -2. And the change in x would be going from -2 to -1, which is +1. So my slope fraction would be -2 divided by 1. And if we can simplify, we always want to simplify, and that would give us just -2. All right, once you have your slope, you are ready to write your equation. So your equation is going to start the way that our equations always start. Our output variable is y and our input variable is x. So our equation is going to start y of x is equal to. Then we need our starting value. Now the starting value in this table is 6. So we would start with 6. And then we need our pattern. Our pattern this time is going to be our slope, which is going to be -2. And then parentheses x. And then we need our starting input value, which is -2. We need to get back to 0. So instead of just x, it would be x plus 2. And that would be your equation. So hopefully this looks very similar to how we've done writing equations before. It's just that now instead of just the pattern of the y's, we also need to find the entire slope because the x's are not necessarily going up by 1. Let's do another problem. So the first thing I would do here is I would find my slope. Now my slope is going to be a fraction, and my fraction is going to be the change in y divided by the change in x. In this case, change in y, if we go from 3 to 5, would be +2. And change in x, if we go from 0 to 2, would be +2. So my slope fraction would be 2 over 2, which simplifies to just 1. Now my equation is going to start the same way my equations always start. Y of x is equal to my starting output, which is 3, and then my pattern, which is +1, and then parentheses x, and then I need to decide if I need to get back to 0. In this case, since the starting x value here is 0, we can just leave this as x. For the next problem, let's do this one more time. So we're going to need to find our slope first, which is going to be change in y divided by change in x. Now my change in y here is going to go from 10 to 16 is plus 6. And my change in x here is going to go from 4 to 7, which is plus 3. And 6 divided by 3 does simplify, and it gives me 2. So my equation is going to start y of x is equal to, and I'm going to have my starting value, which is 10, plus my pattern, which is 2, parentheses x, and then I need to get back to 0. So since this starts with 4, I would put minus 4 here. Okay. Hopefully, other than the fact that we have to find the slope here, this looks very similar to what you remember doing from Module 1. Now, what we're going to do next is we're going to talk about the two different ways that our equations looked. So what you'll notice is that in this equation right here, and in this equation right here, both of these equations required us to adjust the equation to get back to 0. So we have this plus 2 and we have this minus 4. That type of equation is called point-slope form. Now, point-slope form can look a couple different ways. So one example would be like this. I'm just copying the equation from the first example problem that we did here. Another option, though, is that sometimes point-slope form, they just kind of flip-flop the order that these are written in. So they put the -2 parentheses x plus 2 first, and then a plus 6 at the end. Either way, this is called point-slope form. And the reason it's called that is because we needed to adjust the x to get back to 0. So that is what makes this point-slope form. We can write the equation of a line using any starting point and the slope of a line. The only rule is we do need to adjust the equation to get x back to 0. And the reason we call this point-slope form is because it uses any starting point and the slope. So that's where the name comes from. Now, the other equation that we wrote here, this one, looks a little bit different. And the reason it looks a little bit different is we did not need to adjust to get back to 0. This is called slope-intercept form. So I'm going to go ahead and copy that equation down. I'm not changing anything. It's just 3 plus 1x, or some people like to put the 1x first, and they would just flip-flop the order here, and they would have 1x plus 3. When the starting point of the line is the x-intercept, sorry, not x-intercept, is the y-intercept, it means the x value is 0. So you'll notice in this table, the x was 0, that is the y-intercept. And we give this type of equation a special name. We call it slope-intercept form. And the thing that makes this slope-intercept form is that we did not need to adjust to get back to 0. We already started at 0. And so if you look at the difference, this equation has a parentheses because we had to adjust, and this equation does not have a parentheses because no adjustment was necessary. Or if it does have a parentheses, it's just an x. We didn't have to shift it at all. Now, let's go ahead and try some problems. And what we're going to do for each of these problems is write the equation and then identify whether that equation is point-slope form or slope-intercept form. So once you've got your equation, we're going to determine the type of the name of that equation, because that vocabulary is going to be important kind of in the future, to know the names of those equations. All right, so If I gave you this table, the first thing you would want to do is find your slope. Now, in order to find your slope, you're going to need change in y over change in x. And so in this table, to go from 22 to 15, you are subtracting 7. And to go from -3 to 0, you're adding 3, which means your slope would be 7 over 3, and that does not simplify. Now, if you want to write your equation, we're going to use y of x equals our starting point, which is 22, and then our pattern, which is plus 7/3, and then parentheses x, and then we have to get back to 0, so plus 3. Now, because of that adjustment, because we needed to get back to 0, we would call this type of equation point-slope form, because we used some starting point, but not a special starting point where the x was already 0, which we call the y-intercept. For problem number 2, it says write the equation of a line going through the point 5, 2, and with a slope of -3. So what I want you to understand is that when we read a problem like this problem is telling us the starting point and the pattern already. So if you use your imagination, this would be a table where the first set of numbers in the table is 5, 2, and after you did all your work, you already figured out that the slope was -3. We didn't have to do all this work. We already know it. What that means is we can just write our equation. So we would have y of x equals our starting y, which is 2, plus our pattern. In this case, that would be -3, parentheses x, and then we need to adjust to get back to 0. So because this starts with 5, you would put -5 here. Now, because we needed to adjust to get back to 0, we would call this point-slope form for the type of equation. We're using a random starting point and the slope. For problem number 3, we're going to do this one in a very similar way. So if you use your imagination, this would be a table where the first point was 5, 3, and the second point was -1, 8. Now for this problem, we don't know the slope yet, so that's going to be our first step. We're going to need to find the slope, which is going to be change in y divided by change in x. Now, to go from 3 to 8 here, we're going to do plus 5. And to go from 5 to -1, we would have to do -6. So my slope here would be 5 divided by -6. When I want to write my equation, I would start with y of x equals my starting y, which is 3, plus my pattern. Now in this case, because the pattern has a negative, I would put -5/6, and then parentheses x, and then we need to get back to 0. So we're going to put x -5. And that would be my equation. Now, because my starting point did not start with 0, I would call that point-slope form. For the next problem, my suggestion is going to be to find 2 nice points on the graph. So here are the 2 nice points. I'm going to make an XY table. My first point is -1, 0, and my next point is 0, -4. So for this point, it's left 1, up 0, and this point is over 0, down 4. Now we can find our slope in a couple different ways. We could do it from the table or from the graph. If we want to do it from the graph, just to review that, we would do rise over run, which is, in this problem, the rise would be 4, and the run would be -1. If you did look at the table instead, you would do from 0 to 4 is -4, and from -1 to 0 is 1, which would give you the same fraction because it would both simplify to -4. So if you did the fraction from the table, you would have -4 divided by +1. But either way you get, it simplifies to -4 when you divide. So it doesn't matter how you do the slope here, you can do it either way. My equation would start y of x equals my starting value, which is 0, and then my pattern, which is -4, and then parentheses x, and then I need to adjust to get back to 0, so I would put +1. And that would be my equation. Now again, since my equation did not start with 0, I would have, this is called point-slope form. Last but not least, for number 5, if we wanted to write the equation of this line, I would do it the same exact way. So I would find 2 nice points and I would make a table. My starting point would be 2, 3. And my next point would be 5, 4. I can find my slope in a couple different ways. I'm going to do rise over run. So up 1, over 3, and that's my slope. So my equation would be y parentheses x equals my starting output, which is 3, and then my pattern, which is +1/3, parentheses x, and then we need to get back to 0, which means we need to put -2. And again, this would be point-slope form of the equation of a line. All right, that is it for today. Thank you guys so much for watching, and I will see you for some practice in class.